Hello viewers, welcome to my channel and thank you for watching the videos. In this video, question 6b of 1994 analytic geometry. So if the normals at the points alpha, beta, gamma, delta on the conic 1 upon r is equal to 1 plus e cos theta meet at rho phi, prove that alpha plus beta plus gamma plus delta is equal to 2 phi is equal to odd multiple of pi radians. So solution is 1 upon r is equal to 1 plus e cos theta. This is given conic equation. The equation of normal to the conic equation, that is to the equation 1 at any point lambda on it is LE sin lambda upon 1 plus E cos lambda. This you have to remember. 1 upon R is equal to sin theta minus lambda plus E sin theta. Now if it is passes through rho phi, we have LE sin lambda is equal to rho 1 plus E cos lambda, then minus cos phi sin lambda plus E sin phi. This is equation 2. Now we put sin lambda is equal to 2t upon 1 plus t square. Cos lambda is equal to 1 minus t square upon 1 plus t square. And where t is equal to 10 lambda upon 2. So equation 2 becomes LE 2t upon 1 plus t square is equal to rho 1 plus E cos lambda. So cos lambda is 1 minus t square upon 1 plus t square sin phi. Cos lambda is 1 minus t square upon 1 plus t square minus cos phi. Sin lambda is 2t upon 1 plus t square plus E sin phi. This is equation 2. We can say 2 is already. Now simplify it. So we take LCM and on left hand side 1 plus t square, on right hand side 1 plus t square into 1 plus t square. So this becomes 2 LET and 1 plus t square because cross multiplication. Then rho and 1 plus t square in denominator cancel out, 1 and 1 has been multiplied. Rho, then we take here LCM 1 plus t square. So this becomes 1 plus t square plus E 1 minus t square sin phi. So this becomes sin phi minus t square sin phi plus E sin phi minus cos phi 2t upon 1 plus t square 2 LET 1 plus t square is equal to rho 1 plus e then plus t square 1 minus e into sin phi 1 plus e. It will not be here. Minus t square sin phi minus 2t cos phi. Now we open it. 2 LET plus 2 LET cube is equal to rho bracket 1 plus e whole square sin phi minus 1 minus e square t square sin phi minus 2t 1 plus e cos phi plus t square 1 minus e square sin phi minus t4 sin phi 1 minus e whole square minus 2t cube cos phi. So here t square 1 minus e square sin phi, this will cancel out. Now we write first t to the power 4 term and then t cube terms, t cube here also. So this becomes rho, because we are taking on left hand side rho 1 minus e whole square sin phi t to the power 4. Now t cube terms plus 2 le minus 2 rho and with this we have 1 minus e also. So 1 minus e cos phi t cube. Then we have t square is 0, no term of t square, and then constant terms, one is this and another will be only one, but we have t terms also. This is t term and this is t term, so plus 2 le plus 2 1 plus e cos phi into t and then constant minus rho 1 plus e square sin phi is equal to 0. The previous equation, we call it equation 3, being of degree 4 in t. So what will give? It will give 4 roots. So 4 roots of 4 values of t, and what is 4 values of 10 lambda by 2 because t is 10 lambda by 2. Thus there are 4 points on the conic, say alpha, beta, gamma and delta, and the normal set which pass through the point rho phi. So let values are T1, T2, T3, T4. These are the roots. So we will have T1 is 10 alpha by 2, T2 is 10 beta by 2, T3 is 10 gamma by 2 and T4 is 10 delta by 2. So summation is S1 is sigma T1, which is equal to minus twice of LE plus 1 minus E rho cos phi upon rho 1 minus E whole square sin phi. What is it? Basically, we are taking the coefficient of t cube, this is coefficient of t cube upon, and with minus sign, and upon the coefficient of t to the power 4. Then we take S2 sigma T1 T2. This will be 0 because coefficient of t square is 0. Then S3 is sigma T1 T2 T3. It will be minus coefficient of t with minus sign, plus minus plus minus, so minus plus minus plus, so minus plus minus 2 LE plus 1 plus E rho cos phi, this is coefficient of t, upon coefficient of t to the power 4 rho 1 minus E whole square sin phi, and S4 is T1, T2, T3, T4. This is the constant term and it will be with plus sign, so minus, because it is in minus 1 plus E whole square sin phi upon rho 1 minus E square sin phi. It will cancel out, so rho, so this comes minus 1 plus E whole square upon 1 minus E whole square. The last relation may be written as this one, 10 alpha by 2, 10 beta by 2, 10 gamma by 2, 10 delta by 2 is equal to minus 1 plus E whole square upon 1 minus E whole square, and 10 alpha by 2 plus beta by 2 plus gamma by 2 plus delta by 2 is equal to S1 minus S2 upon 1 minus S2 plus S4. This you have to remember the formula. Put the values. So values are is equal to minus 2 LE plus 1 minus E rho cos phi upon rho 1 minus e whole square sine phi plus 2le into S2. S2 is this is S3. S2 minus S3. So this is 2 Le 1 plus E rho cos phi upon E 1 minus E whole square sine phi, and this will be upon 1 minus 0 because S2 is 0 minus 1 plus E whole square upon 1 minus E whole square. So this comes 2 into 2 rho E, because what happens, this is the LCM. So we will be having 2 into 2 rho E from here, rho E cos phi, because this 2Le cos phi into rho. So from here plus 2E rho cos phi, and from here 2 rho E. When we put the values of this is S1 minus S3 upon 1 minus S2 plus S4. We put the values, it comes minus 2Le plus 1 minus E rho cos phi upon rho 1 minus E square sine phi plus 2Le plus 1 plus E rho cos phi upon rho 1 minus E whole square sine phi, and this. So this comes 2 into 2 rho E cos phi into 1 minus E. This we take upwards after taking LCM upon rho 1 minus E whole square sine phi. This was from LCM, and when we write this term 1 minus E whole square minus 1 plus E whole square, this gives minus 4E. So this comes is equal to minus cot phi. Why is it cot phi? Because 1 minus E square, this cancels out, rho is cancelled out, E is cancelled out, 4, this minus 1, this is there, and then cot phi. So minus cot phi is equal to 10 pi by 2 plus phi. So it gives alpha plus alpha by 2, beta by 2 plus gamma by 2 plus delta by 2, because left hand side is in 10 and right hand side is also 10, so we can compare the angle, and this comes pi by 2 plus phi. So we can write down alpha plus beta plus gamma plus delta upon 2 is equal to n pi plus pi by 2 plus phi. N is any integer. So we cross multiply alpha plus beta plus gamma plus delta is equal to 2n, because here we take LCM, and then cross multiply. So 2n plus 1 pi, 2n plus 1 pi, and upon 2 into 2 plus 2 pi. So this becomes, which is an odd multiple of pi radians. Thank you.